Let's talk about what the exponential equation means and what it looks like. The exponential equation is frequently written as f of x equals a times b to the x. Sometimes there's a number added in plus a c. That's just a translation. It just shifts the whole value. The important parts are a and b. A is the original value or starting point, and b is the factor of change, the factor of increase or factor of decrease. Sometimes b is written as 1 plus or minus some rate. This is especially useful when we're working with changes in percentage. What is a? A is the initial value, or the starting point. So if we start with 2,500 bacteria cells in a culture, A is 2,500. What is B? It's the growth rate. It controls the speed of the growth. So I say here it's loosely related to slope. That's not a good way to think about it, but it does have to do with the rate of change. So if B is a big number, your exponential equation is increasing really fast. If b is less than 1, your exponential equation is actually decreasing as x increases. So an initial population of 100 means a equals 100, and a growth factor of 13%, a growth rate of 13% looks like P of t equals 100, there's our A value, and then our B is 1.13. So the growth rate is 13%, we change that to a decimal, and this 1.13, if we think about B as 1 plus or minus the growth rate, B equals 1 plus 0.13, or B equals 1.13. If we have a decay rate instead of a growth rate, it's also useful to think about it as B equals 1 plus or minus R. So a decay rate, instead of adding that percentage in, we're going to subtract it out. So in this case, the decay rate of 3% means that our B value is 1 minus 0.03. This works out to be B equals 0.97. So our equation looks like P of t equals the initial value of A times 0.97 raised to some power. So this power, I'm kind of jumping back and forth between it being t versus it being x. This value is just the input, and it's frequently given in time, but not always. F of x, what this equals, is the output, or the population, or whatever it is you're looking at a certain point in time. Let's do a few problems. These examples are actually from Khan Academy Exponential Expressions word problems. The town of Springfield, USA has a population of 9,900 people. So that's our initial value. That is going to be our A value. If we're looking at this as P of t equals A times B to the t power. So A is 9,900. The population is growing at a rate of 2.3% each year. Since this is a percentage growth rate, I'm going to think of this as 0.023, and I'm going to think of my B value as being 1 plus, since it's growing, R. So that means our B value is 1 plus 0.023. So which expression gives the town's population 5 years from now? Well, we have our initial value of 9,900. I know already it's not these last two because there's no case where we're taking our initial value and adding it in. It's always going to be multiplied, A times B to the t power. This first case is close, but there's no 1 plus the percentage. It's just 0.023. what we want is this answer. 9,900 times 1 plus 0.023 raised to the 5th power. Kareem sent a chain email to 10 of his friends. So again, that 10, that's our initial value. That's our A. The number of people who got the email increased by a factor of 1.4 each week. When we see growth rate, we're usually talking about a percentage, and we think of our B value as 1 plus or minus R. When we talk about growth factors, just look at B itself, because that means the growth factor overall, the whole thing, is increasing by a factor of 1.4 each week. So that means A equals 10 and B equals 1.4. So writing this just as an expression, we have A times B to the X power. The time is 6 weeks, so that means the X value is going to be 6. And we have 10 times 1.4 raised to the 6th power. Option A it is. We can even build our own equations. On the day that a certain celebrity proposes marriage, 10 people know about it. You probably know this by now, but there's our initial value, A equals 10. Each day afterward, the number of people who know triples. We're supposed to write a function that gives the total number of people who know about the celebrity proposing T days after the celebrity proposes. Let's work out a few of these so we can get the hang of it. At T equals 0, day 0, 10 people know about it. N of 0 equals 10. The very next day, though, the number of people who know about this triples. So at day 1, it's not going to be 10 anymore, it's going to be 30. On day 2, that continues to triple, so it's not going to be 30 anymore, it's going to be 3 times 30, or 90. On day 3, the number of people who know about it triples again, so 90 times 3 is 270. So what I see here is I have a base of 10, or I have a starting value of 10, and then I'm multiplying by 3 each time. Times 3, times 3, times 3. So what my equation is going to look like is the number of people start with an initial value of 10, and then it gets multiplied by 3 each day. That is our equation. That is in the form of f of x equals the initial value times the growth factor raised to some power. Yes, that should be an x. One last question. The expression 5 times 2 to the t power gives the number of leaves on a plant as a function of the number of weeks since it was planted. So looking at this a little bit, I know when t equals 0, the expression is going to become 5 times 2 to the 0 power. Anything to the 0 power is 1, so 5 times 1 is just 5. When t equals 1, 5 times 2 to the first power is 10. When t equals 2, 5 times 2 squared is 4. 4 times 5 is 20. When t equals 3, 2 to the third power is 8. 5 times 8 is 40. So in this problem, this number right here, so this column, is the number of leaves on a plant. And this is based on the number of weeks since it was planted. So this column is number of weeks. What does the 2 in this expression, what does that 2 represent? 2 is not the number of weeks, so that's not option A. It's also not the number of leaves, so it's not option C. It's the number of leaves is multiplied by 2 each week. And sure enough, when we increase t, what we were doing is we were multiplying by another 2. 5 times 2 is 10, times 2 is 20, times 2 is 40. That is our right answer. I hope this video helps you understand a little bit more about how exponential functions work. Thank you.